Have you ever wondered why stars twinkle at night? In the vast expanse of the universe, stars are celestial bodies that light up the skies, creating a spectacle of twinkling beauty. But these stars are more than just glittering specks in the night sky. They are fiery furnaces of nuclear reactions with lives that span billions of years. Stars are born, they grow, and they die just like us. They undergo a fascinating journey, a life cycle that is as intriguing as it is complex. The life cycle of stars is a cosmic dance of transformation, a symphony of celestial processes that shape and reshape the universe. Our journey begins with a star's birth, born from clouds of dust and gas known as nebulae. These celestial nurseries are where stars begin their life, kindling their nuclear fires and starting their journey towards maturity. As stars age, they grow, fueled by nuclear reactions at their cores. They spend most of their lives in a stage called the main sequence, a period of stability and equilibrium. But even the longest-lived stars can't remain in this state forever. As their fuel dwindles, stars undergo dramatic changes, swelling into red giants or shrinking into white dwarfs depending on their mass. Eventually, all stars reach the end of their lives. For some, this comes in a gentle fade into obscurity, slowly cooling and dimming until they are no more. For others, it's a violent end in a supernova explosion, a final spectacular burst of light and energy that can outshine entire galaxies. But even in death, stars continue to contribute to the universe. Their remains seed the cosmos with the elements necessary for new stars, new planets, and perhaps even new life. The cycle of birth, growth, and death continues, an endless waltz played out across the vast stage of the universe. Understanding the life cycle of stars helps us understand the universe itself, for stars are the building blocks of galaxies, the engines of creation and destruction in the cosmos. So buckle up as we dive into the mesmerizing journey of a star's life cycle. Every star, just like us, starts from a humble beginning. Picture the vast cosmos, a sea of darkness punctuated by nebulae. These are massive, majestic clouds of dust and gas. They're the stellar nurseries, the birthplaces of all stars. But how does a star emerge from these cosmic clouds? Well, it all begins with a disturbance. Perhaps a nearby supernova explosion, a powerful shockwave, or the gravitational pull of a passing star. This disturbance sends ripples through the nebula, causing particles of dust and gas to clump together. These clumps grow denser and denser, their gravitational pull getting stronger, drawing in more and more matter. This process is known as accretion. As these clumps continue to grow, they form what we call a protostar, the earliest stage of a star's life. But our baby star isn't shining just yet. For that to happen, we need to stoke the fire. And in the universe, that means building up pressure and temperature. In the heart of the protostar, the pressure becomes so intense that hydrogen atoms start to fuse together, creating helium. This process is called nuclear fusion, and it's the same reaction that powers our sun and every other star in the universe. As these atoms fuse, they release an enormous amount of energy in the form of heat and light. And voila, our protostar starts to shine, beginning its life as a bona fide star. But the birth of a star isn't a swift process. It can take millions, even billions of years for a star to fully form. The star continues to shine, burning hydrogen into helium for as long as it has fuel. Depending on its size, it could shine for billions of years more, illuminating the cosmos and providing the heat and light necessary for life as we know it. And there you have it, the birth of a star. Just like a child growing into an adult, stars too have their growing phase. Imagine a child, growing and learning, transforming into a mature, capable adult. This is a lot like a star's journey through the cosmos. The majority of a star's life, often billions of years, is spent in what astronomers call the main sequence. This is the star's growing phase, its adolescence if you will, and it's when the star is at its brightest. During this main sequence phase, a star is essentially a gigantic nuclear fusion reactor. At its core, it's busily converting hydrogen into helium. This process releases a tremendous amount of energy in the form of light and heat. This is what makes the star shine so brightly, cutting through the inky blackness of space. Now you might be wondering, why does a star burn hydrogen? Well, it's a matter of survival. Stars are essentially in a constant battle against gravity. The star's own mass is trying to crush it under its weight. The only thing stopping this from happening is the outward pressure generated by the energy from nuclear fusion. It's a delicate balance, a cosmic dance between the forces of gravity and energy. And this dance can go on for quite some time. A star like our sun can happily burn hydrogen for about 10 billion years. Larger stars burn through their hydrogen much faster, while smaller stars can keep the dance going for much longer, sometimes for hundreds of billions of years. During this time, the star is stable, consistent, and predictably bright. It's a beacon in the dark, a point of light that has guided mariners, inspired poets, and intrigued astronomers down through the ages. So when you see a star twinkling brightly in the night sky, you're most likely looking at a star in its prime. It's in the main sequence of its life, burning brightly, and providing energy to any planets that might be lucky enough to orbit around it. It's a cosmic powerhouse, a shining example of the awesome power of nature. So, when you see a star twinkling brightly in the night sky, you're most likely looking at a star in its prime. Everything that begins must end, and stars are no exception. Like the final act in a grand play, the last stages in a star's life are dramatic and full of suspense. The star, once a blazing beacon of light and energy, starts to change. It begins to expand, swelling into what we call a red giant, or, in the case of larger stars, a supergiant. This change is not a sign of growth, but rather an indication that the star is running out of fuel. You see, stars shine because of nuclear reactions happening at their core. These reactions convert hydrogen into helium, releasing an enormous amount of energy. But eventually, hydrogen starts to run out, and the star begins to burn helium instead. This new fuel source causes the star to expand, turning it into a red giant or supergiant. But even this stage doesn't last forever. As the star exhausts its helium fuel, it starts to collapse under its own gravity. This is when things really get interesting. What happens next depends on the mass of the star. If the star is about the same size as our sun, it will shed its outer layers and leave behind a dense core known as a white dwarf. This white dwarf will slowly cool and fade over billions of years. If the star is larger, the collapse might trigger a massive explosion known as a supernova. This explosion is so powerful that it can briefly outshine an entire galaxy. What's left after a supernova can become a neutron star, an incredibly dense object made mostly of neutrons. If the star is truly massive, the collapse can form a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. And thus, a star's journey comes to an end, but not without leaving a significant impact on the universe. Each stage of a star's life contributes to the cosmic dance of creation and destruction, and even in death, stars continue to shape the universe in profound and beautiful ways. A star's end is not a full stop, but a comma in the cosmic story. You see, the grand finale of a star's life, the supernova, is not just an ending, but a new beginning. The explosion casts off the outer layers of the star into the surrounding space, scattering elements far and wide. Among these elements are the very building blocks of life as we know it, including carbon, nitrogen, and oxygen. Imagine it like a cosmic recycling program. The remnants of the supernova, enriched with these elements, mingle with existing interstellar matter, forming a nebulous cloud. This cloud, under the right conditions, can collapse under its own gravity. And what happens next? You guessed it. A new star begins to form. Thus, the cycle continues. From the birth of a star in a dense cloud of gas and dust, to its maturing years as it burns hydrogen to create helium, its life is a marvel of cosmic engineering. And when it exhausts its nuclear fuel, it meets its end in a spectacular supernova, only to give rise to a new generation of stars. It's a process as old as the universe itself, a never-ending cycle of birth, life, death, and rebirth. But it's not just stars that are born from this process. Planets, asteroids, and even life itself owe their existence to the elements forged in the heart of stars and scattered across the cosmos in these spectacular explosions. So, in a way, we are all made of star stuff, connected to the cosmos by the very elements that make up our bodies. The life cycle of stars is not just a story of cosmic proportions, but a story that is intimately tied to our own existence. So the next time you gaze up at the twinkling stars, remember each one is at its own stage in this incredible journey we've shared with you today.